button where it says raise hand. In the question area, write down the question you may have. And at the end of the webinar, we'll go through all of the questions and I'll try to answer them to the best of my abilities. Again, click on raise hand. In the question area, write the question down. When you finish writing the question down, click on send, and then we will start answering the questions at the end of the webinar. Okay. Well, I'm going to first load a little PowerPoint, and we'll go through the PowerPoint just to make sure we don't miss anything. There are points over here that I brought up last week, so those I'm just going to skip over. So as I go down on my list, last week we did discuss about a single file in using a SolidCAM, using a SolidWorks part, everything within the part itself, we call internal mode. We discussed that last week, so let's go to our next subject. Now, one thing I did not mention last week is that we now have the option, or I should say it's not an option, it's actually the way SolidCAM works now. When you have large parts, when I'm talking about large parts, I'm talking about large parts from SolidWorks. Even parts, let's say, you'll start off with them sometimes where they have 80 megabytes or even larger than that. These are large parts in SolidWorks. Now, in our previous versions, the time that it took just to do a simple setup on a part like this would take a long time. This has been reduced dramatically on large parts, as much as 60 to 70% as far as the time to work on these parts itself. We've changed our facetings, the way it's done, the way our memory works with these parts. So those parts now work a lot faster when you starting off a new project in SolidCAM. The targeting facets when you choose it as a target goes a lot quicker. Creating coordinate systems on these kind of parts are also a lot quicker. In general, working with these kind of parts are a lot quicker than they were before. Okay, let's see. Stock we talked about last week. Now, one point I'd like to mention is that every now and then, hopefully very not often at all, sometimes you may get a while you're working, the system may freeze up and you may get a window where it says SolidCAM has stopped working. We now have a window that actually tells us this, and what I'd like everyone to please note is that on the bottom it says send report. If for some reason you do get a window like this when working in SolidCAM, click on send report, because that actually sends us an exact report of what happened on your computer with the part. And we actually do look at these, we get these reports, and we can actually act on these reports as well. It'll make also QA a lot better on the program itself, and bug defining on the bug checking on the program is also a lot easier for us to work with, making it also a lot better for you at the end because we get it fixed a lot quicker. Okay. Just a quick note, in our general view, in our SolidCAM view, we've added some more icons over here, mainly for the turning mode and an isometric mode, as shown over here. Okay, this we talked about. In fact, we cleaned up the settings. And let me just take a quick word about our tool table export and import format. And I'll open up the program for that. And let me go into my SolidCAM settings. Excuse me. By the way, today's webinar will not be a long one. It will all be anywhere somewhere about a half hour to 35 minutes. Okay. If we take a look at the tool table, we have now the import options as shown over here. First of all, as far as the import options, we have, as we've always had, where to import with our table from, but more so, what is the format that you would like the import to automatically open up as. That we choose our default tool table, whether it be from the default tool table format, whether it be from ISCAR Tool Advisor, whether it be from our tabs, which is regular table that we've had up until now, whether it be from from a part that we have directly from tool tables that we have in parts, to open that up automatically. This, by the way, even though you may have a default over here, as you're working, you can always choose from any one of the options. But the default will be whatever is written in this area over here as far as importing a tool. Okay. Okay, just one more note. Also, if I didn't mention this before, we have actually now hotkeys for several typical window operations. For renaming an operation, just click on F2, Control X, Control C, Control V for copy, paste, and cut, just like in Windows. And also for deleting, just click on the operation, click delete on your DEL on your keyboard, and it'll work exactly like you would expect it to work. Okay. We will also have the option of, in your tool tree, to be able to see your tool offset numbers in the CAM tree itself as well. Okay, one moment please. חבר'ה, שקט בבקשה. Okay, sorry, I've returned. Okay. Okay, suppress G code we talked about. Okay, you can also create now a tool sheet from just one specific operation. If you want to have a specific operation, create a tool sheet on that particular operation. This can be done now as well. Okay, the tool tables, we've talked about this last week. Shape tools. Okay, let's take a quick look at any of our operations right now. I'll just open up this one, and if we go to our section where we create our tools, as shown over here, you'll note that now the besides the tool diameter appearing here and the radius, we also have the cutting length appears over here and outside holder appears over here. You don't have to go to select in order to see what those values are. It all appears within that window itself, as shown over here. You don't have to look over here all the time. And this is, by the way, very important, especially when you're working with HSM, to always know what the cutting length is. You don't have to always go back and check. You can just see it right here. And also just for checking how far your tool is hanging out the holder itself. All this is available right here in front of us. Okay. Next. Okay, minimizing the tool operation dialog. We've seen that. Those we've seen last week. Okay. Let's go now into our toolbox. We've made some improvements in our toolbox, and I'll go into our operation over here for that. First, with operations such as the open slot, as shown over here. This slot that's over here, spiral open slot. We now have in our technology that besides our having it either at 0 or a wall offset, When you had a wall offset, you were not able to do a wall finish. There was no option of wall finish. Now we've added also to be able to do both roughing and finish within the same operation. Taking a look at this operation itself, you'll see we have a wall offset, for example, of 0.5 of a millimeter, and we're using wall finish. If we take a look at our simulation, and let me use actually our 2D simulation for this, you can see our geometry over here, and I'll try to run this a little slow over here. You see our tool. Actually, let me start this again. This time I'll show my tool. There we go. You can see our tool is going up over here. I'll stop it. You'll note that it leaves material off at the end over here, the 0.5 millimeter like I asked it to, and then it'll go back and clear off those sides as well. So this before you had to do two separate operations to do this. Now this is all done within one operation of the toolbox. Sorry. Now, another improvement we've made in Toolbox is also the option of O-ring. If I were to open up our O-ring option over here, and I've created an operation here already, we have our typical O-ring, we have our levels, how deep we want to go, and then we have our technology. Now, we've added an option of technology in our technology of approach angle and retract angle. Before we had step down. Let's say I had a step down of 1 millimeter, so every single time it made a full turn around the O-ring itself, it would actually move down 1 millimeter at a time. Now we can tell it, instead of going down 1 millimeter, we want it to go down according to a specific angle. Okay? Now, let me just run the simulation on step down the way it is. And I'll use the option of HostCAD to show this. What you'll see is very simple. The tool, hold on, let me get rid of that as well. There we go. And I'll even hide our target over here so we can actually see just the tool path itself. Sorry, I said hide. Okay, having a little bit of computer problem. Okay, in any case, let's take a look what's going on here. You'll note our tool goes down and then starts working around, going down every millimeter. Now we've added an option here. Instead of working that way, we can say, let's go down at a specific angle. Let's say we're going to want to go down 1 millimeter angle approach, and then when you come back up at say 5 millimeters. Note when you do that, this is grayed out because now you're working according to approach angles and retract angle instead of a step down. What'll happen is now it'll go around, but this time instead of going down 1 millimeter, it'll go down actually at a specified angle. If I do this, let me go here, back here a little so you can see this a little better. One step at a time. You'll see that's actually going down according to that 1 degree over there. You note this time you have a lot less step downs. It's going according to the actual value of the angle. Now your retreat, you'll see that your retreat actually is going up at a specific angle. Let me just catch the retreat itself. You can see the retreat over here is going up at the 5 degrees according to the shape, along the shape of the geometry itself. So we've added that inside our option of O-ring. Now, let's go continue on. We'll get back to this part in a moment. Okay, in our threading option of thread mill, we've added the option of having a different feed for our lead in and our lead out. We can slow down our feed rate or speed up our feed rate accordingly when we lead in and lead out of our threads itself. Now, we've added now a new option for engraving text. When doing text, you used to have a sketch over the part or something on the part itself in order to do the text. We've actually created the option now inside creating a geometry that you do not have to do this anymore. Okay? For example, I'd like to create a text on this surface over here. Let me just take this to my top view as shown over here. I want to work over here on this surface, but I want to have a text written in over here. Now, I'm not going to create a sketch. Instead, I'm going to go, let's first go into our operation. Let's go to a simple profile operation. Okay, if I create a geometry now, we have the option in creating a geometry of adding text. Okay, if I click on add text, you'll note I have an edit window over here. By going into edit, I can actually write text in this window over here. Over here you can see we have the fonts. Choose any font you want to have, no problem. The size of the font, and if I want to write the text, all I do is click on text, drag a window, and write anything I want. Say I'm going to write something over here. Excuse me. And I'll click on OK. That's the text I want. Now, where do I want the text on the part? Well, right now it gives you the point according to the 0 point over here. I can actually write in a value over here, or I can actually pick a point on the part itself. For example, if I want to just pick this point right over here, click on resume, click on OK, and our text will be over here. If I want to have a preview of my geometry, no problem. We have our preview of our geometry over there. I'll just accept that, and you can see that we have our text on the part itself. And then we work on the part just like any other text in the past, but this time I did not have to create a text on the part itself. I'll go into tools, I'll choose an engraving tool. I'm having a little computer issue over here, so it's working a little slow. Engraving, select. We have an engraving tool over here. Levels, I want to go down 0.2 millimeters. In our technology, just leave it exactly the way it is. Let's run our simulation on this part, and I'm going to use actually Solid Verify for the part itself. Okay, and you'll note that the tool is actually going down, doing the text on the part itself, even though I did not have any text written on the part itself. I can do all the text within SolidCAM itself, and you can see I have the text over there. Now, one other thing as far as text goes, let me suppress this operation. There we go, suppress. And I'm going to do another operation where I'm going to use the same type of text that we had now, but many times you'd like to have a single line in the text itself. Now you'll note that the text that we had was a double line text, which is what you normally get from Windows. So what we can do now is we can actually open up engraving over here instead. We'll choose, we have either 2D or 3D. I'll choose the geometry that I just created. And I'll go into tool, choose my tool. Again, I'll choose the engraving tool that I had before. My levels, again, I'll have that at 0.2. And in my technology, I'm going to work in the center. I want my center of the tool to go on the toolpath. However, we have another area over here called fill area. If I open up my fill area, I'm going to choose the option of middle line only, where it'll go only in the exact middle between the two lines over there. Okay, get rid of rise at the ends. I don't want it to actually rise at the end of the point, otherwise we'll get some marks over there. We'll take a look at the simulation. Okay, by the way, this text, if anyone is interested, will be obviously will also be available in InventorCAM if you have InventorCAM. So it'll be available there as well. Okay, I'll run my text. As you can see, the text is being done over there. Let me speed it up a little bit. Take a look at the top view, and you'll see now, whoops, sorry, there you go. You see now that we have a single line instead of a double line like we had before. We obviously still do have the option of the single line text that we had before, but now you can do a single line with any kind of text that you may have. Okay, I'm glad I answered somebody else's question. Okay. Next. Where were we? Yes, we were over here. Okay. We'll leave that. Now I saw a little problem with that. Okay, just for your general information, the HSR HSM smoothing surface works a lot finer now. The actual tolerances are actually sticking a lot closer to the tolerance that you actually gave them. They're not deviating a lot with their nodes. You will get a lot smoother surface now in HSM than you've gotten even before. If you got a smooth surface in HSM now you'll even get it even smoother. Calculation is faster. I mentioned this before because we do use Multicore Calculation in HSR, HSM. And now what I'll actually, oh, one more thing also. In HSR and HSM, if you change fields, if you've actually used a certain particular option in HSM or HSR, and you put in all the values over here inside your paths, and then you decide to change your strategy, the values that you put in will stay the same, will not be changed. You'll keep the values that you put in. Obviously, while you're in that operation. Okay. I'd like to actually go on now to one important subject. And that is, we have made a vast improvement with our 3D iMachining. And I'd actually like to show this to you. Let me just close this part itself. And this has to do with your tools and holders. I'm just going to open up a part that I have over here. And by looking at the part itself, you'll see that obviously what I want to do over here is mill out this area over here. Now the depth between this surface over here and this surface over here is a total of 70 millimeters. If I were to open up my operation itself, okay, opening up the operation itself, I create an operation over here of 3D surfacing with iMachining. I have my tool over here, a 12 millimeter end mill, cutting length 24 millimeters, outside the holder 35 millimeters. We have our level, we have our technology, we have our technology wizard, we have a technology. Let's run our simulation. Now run the simulation in SolidVerify. And the way it's going to work is like you expected it to work, like you known its work up until now, is that when it goes down, it'll go down its step that it has to go down. It'll go down always its maximum step that it can the next time as well. See, my computer's running really slow today. Actually, let me stop this and I'll use SolidVerify for 3D. That may work a little quicker. No, we're having a little problem over there as well. That's not working quick at all. Let's go back to SolidVerify. Actually, I'm going to point. Yeah, here we go. And we just take the time that we need to take. No choice, really. Okay, it's doing the simulation. And as you can see, it goes down its step. I'm not going to go all the way down to the bottom. I just want to get to a specific point. And it clears off the step like we know it does. Okay, let us just run its course for a moment. Thank you. Which gave me, now you know it goes down to its next step, its maximum step down. And it goes down like this all the way to the very bottom. And then what happens at the end, to do its rest roughing, it does it all the way from the bottom, stepping up, which is fine. Now, let me stop this for now. And let's take a look at another option we have here. In our rest rough option, it was working up until now with all steps down and then rest rough. What we can do now is each down step, do a rest rough. Now when you finish that one down step, do a rest rough on that step, then do another step and do a rest rough on that step. This allows, by the way, for more room for the tool to work as it's going down into the part itself. Let's run, save and calculate. Well, I think I know it's a problem over here. Okay, we're running our save and calculate. Just one moment, please. It's still running, don't worry. Okay, here we go. I think I've solved the problem with my computer running too slow. Okay, it's going to finish its calculation now. And what's going to happen now is what you're going to see in the simulation, as the part goes down, it's going to do only one step, do a clear step on that side, a rest rough up and just on that area itself. Then, well, I'm not going to talk too much. You'll actually see it as it happens. I don't want to spoil your fun. Or spoil the surprise for that matter. But there's more that's coming after this. Excuse me. Almost done. I haven't solved my computer problem altogether, but somewhat it did. Okay. We'll run our simulation again in SolidVerify. There you go. It's working faster. Now, it's going to finish the step, and note what happens now. You note now, I would stop at this moment. It started, it's clearing our rest rough already at this point. Now it finishes. Now when it finishes that rest rough, it's going to the next step, and then it's going to finish the rest rough just on the step itself. And that's the way it's going to work on this part. In other words, you're giving yourself more clearance now on the side of the tools as over here, as you're going down on the part itself, by taking away the rest rough over before it goes down. Okay, now let's stop this and go back into our operation. Let's go back to our tool, and we're just going to put a holder on the part itself. Let's see, we're using BT40, so let's go to BT40, and I'm going to use a holder like that one. Okay, typical holder. Run my simulation. Let the calculation go again. Okay, just give it a moment. Sorry for the inconvenience of my computer problem, but next time it won't happen anymore. Good reason for it also. Getting a new computer. Okay. Let the calculation finish. We're going to go through this calculation though one more time, so hold on tight. Not at this point. I wanted first to show you the simulation that we have over here. Okay, it's almost done now. Now if we take a look at the simulation, it'll work exactly like it did before. But this time, when it goes down, what always happened, we'll see it on our next step down, is we had a problem over here because of the way the holder is. Here we go, and there's our problem. You'll note that the holder, because of the way it is, crashes into the stock. Now, what people used to do to remedy this issue is that they had no choice but to take the tool and stick it out, have it stick out a lot longer out of the holder itself. This way, the holder would not touch the stock itself over here. The disadvantage of that is that the more the tool is sticking out of the holder, the more flexible your tool is and the more vibration you may have, so you would have to work at a lower machining level. What we've done now is the following. We've added the option of holder collision. If I actually turn on holder collision, it'll actually check now the holder towards the stock that's left on the part itself. And I can give it a holder clearance of whatever I want. I just gave it a holder clearance of 1 millimeter altogether. Let's take a, sorry, I have to do calculate. Do save and calculate. By the way, just for everyone's information, I'll be starting to now create recordings, SolidCAM Professor recordings on everything that we have in what's new in SolidCAM 2013. So you'll be able to see them in about, I would imagine, about another 2 weeks. You should be able to see them on our website under SolidCAM Professor What's New 2013. And there you'll have recording of every single new option that we have inside SolidCAM 2013. Of course, this webinar is being recorded just like any other webinar that I've done. and you'll be able to see those webinars on our website underneath webinars, recorded webinars, and you'll be able to see these webinars there as well. Okay, let it finish doing its calculation, because now, by the way, as I said, the calculation is also taking into account the actual holder towards the stock. It's checking that the holder will not hit the stock. And we'll take a look in a moment what kind of tool path we're actually going to get on the part itself. Just another moment. Okay, we're almost done. Now it's going to do the rest rough calculation. That goes very quickly. There we go. This part goes quickly, and then we'll take a look at the simulation. Okay, now I'm going to run the simulation again. Again, it starts exactly the way it did this time, last time. But note what happens when it starts getting deeper. Okay, the next step down that it goes, we won't have any problem over there again, because what we had last time, we also didn't have a problem. It was still sticking out enough of the holder so not to actually go into the holder, it's into the material itself. Now this time, when it goes down to the next step, you'll note that it's not reaching the material. It's going deeper and it's creating a little step a little further away. But now you can actually go a lot deeper into the part with the shorter tool being held. And this actually, you'll be working a lot better in iMachining with this kind of situation. Let's run it to the end. You can see the step is larger at this point to make for the clearance between the tool holder and the stock itself. And then since the massive of the material is being removed this way, you can work actually very, very quickly this way without having to worry about the holder, and you don't have to turn down your wizard, your machining level in your wizard. Just keep it the way you want it. You want to machine with it, and just and this will take care of that kind of situation. Of course, your next operation will be another iMachining 3D operation with a tool that does stick out longer, but you'll have that much less material to clear away with that one tool instead of clearing everything that's in the middle over here as well. So now you're just doing it, so then you'll be only doing it on the areas itself over here, which will be less of a problem with that kind of a tool. Okay, so you can see that the larger step ups, the larger step outs over here in the areas where it was doing the clearance from the holder to the stock. You can see it over here, and you can see it here as well. Okay, I'm going to cut it short now. If there are any more questions, anyone could write down the questions. One of the questions that was asked was about the text, which I answered already. Okay, again, just a quick reminder, on our website, you'll be able to see the webinars as recorded. Okay, thank you everyone for joining our webinar. And until our next webinar, take care, have a great day, and of course, have a great weekend.